This is the second of our modules on finance. So in this module, we're going to be discussing annuities, what they are. There are some standard symbols that are used in connection with annuities, and we'll be talking about the formulas. And throughout the video, I will be talking about how you can use a spreadsheet to do the calculations. So an annuity is an account where you make equal monthly deposits over some period of time. So this is different from a savings account, which we discussed in the last module, where you make one initial deposit and then let the money sit. Here's an example to get some idea of what's going on. So let's assume you have a retirement account that pays 24% annual interest, compounded monthly. I know the 24% is unreasonably high, but it makes the numbers easier to deal with for this first example. Okay, and we're assuming you begin with no money in the account, and that at the end of each month you plan to deposit $100. And what we would like to know is how much money will you have at the end of 20 years. So we'll look at how you do this calculation in just a minute, but let's talk about the symbols first. R is the annual interest in decimal form. This is the same symbol we used for annual interest in connection with ordinary compound interest. PMT is the monthly deposit. So in our example, PMT is 100. We're depositing $100 per month. T is the number of years. This is the same as same symbol we used in connection with ordinary compound interest. And A is the ending amount. So T is 20 in our example, and in our example we want to find A. In our study of annuities, we will always assume that you begin with a balance of 0. And we will always assume that the number of compounding periods in a year is 12. So this will just make our calculations a little easier. And here's the formula for the ending amount. The ending amount is the monthly payment times 1 plus the annual interest over 12 raised to the power 12 times t minus 1, and all that divided by the annual interest over 12. So this formula is a little more complicated than the plain compound interest formula, but you may recognize this part of the formula. That also appears in the ordinary compound interest formula. So on some calculators and spreadsheets, you will need all of these parentheses. I've used square brackets here just for a little bit of variety, but on a calculator or a spreadsheet, those square brackets will be parentheses. So let's go back to our example and calculate the ending amount. We had an annuity that earned 24% annual interest, compounded monthly. We're going to deposit $100 a month at the end of each month for 20 years. So we can calculate the ending amount by plugging into this formula that's here at the top of the slide. So I replace the PMT by 100, the R by 0.24, and the T by 20. And I did the calculations and got $574,443.68 to the nearest cent. So, if you're using a calculator, what you enter may look like this. This is exactly what I had entered on the previous slide, except here it all appears on a single line, as it does on many calculators. And notice that I have used all the parentheses that appear in the formula. So I used a spreadsheet to do these calculations. And this is what I recommend. And if you are interested in using a spreadsheet, in particular Google Sheets, you can look at the Module 2 video on using Google Sheets. But here's what the spreadsheet that I used looks like. So I have put the monthly deposit, that's PMT, in cell A3. I have put R, the annual interest, in cell B3. And I put the number of years, that's 20 in our problem, in cell C3. And then in cell B5, which is the cell I was in when this screenshot was taken, is the formula for annuities. So this box contains the formula for annuities. I have A3 instead of PMT because the payment occurs in cell A3. I have B3 instead of R because R occurs in cell B3 and so on. And as we saw before, the ending value is $574,000. Try that once more, $574,443.68 if you round to the nearest cent. Right, and as I said, the formula for calculating the ending amount in an annuity is actually in cell B5. As we know, in the body of the spreadsheet, the calculation is done and a number appears. The calculations can be done pretty efficiently using the Desmos online calculator that I talked about earlier. I'm going to switch to the Desmos calculator. If you are just looking at the slides and not the video, you'll have to come back to the video to see this Desmos demonstration. So here we are at the Desmos online calculator, and you see that here in box number 1 on the left-hand side of the screen, I have entered the formula for annuities, for the ending value of an annuity. The only change I had to make is I'm using P in this formula rather than PMT, because in Desmos variables have to be a single letter. So we got to keep in mind that this P is actually the monthly payment. And you notice toward the bottom of this rectangle, this little box with a blue background and the word all. If you click on that box, then in the next 3 cells will appear places where you can enter values for P, R, and T. They give you a default value of 1 for P, R, and T, and they give you a little slider that you can use to adjust the value, but for our purposes we will just ignore that. So what I want to enter is our monthly payment, which in this case was $100. And our annual interest, expressed as a decimal, 0.24, and the number of years, which in our problem was 20. And then in the lower right corner of the top cell, the value for A appears. A with P replaced by 100, R by 2.4, and T by 20. And now if you have another annuity problem, you can simply adjust the values of P, R, and T, and the new value of A will appear in this lower right corner. So for example, if P is 700, I could enter 700 for P, and the new ending value would appear here. So this is also a pretty efficient way of doing these annuity calculations. Okay, besides calculating the ending value, there are two other calculations that we will be doing with annuities. We will be interested in calculating the total amount of interest you earned. And we will be interested in finding what your monthly contribution has to be if you have some ending value in mind. So if you have a goal, if you want to have $1 million in 40 years, it would be nice to know how much you would have to contribute each month. Finding the total interest is fairly easy, and you could probably do this without a formula. It's simply the ending value of the annuity minus all the contributions you made. So if you take what you ended up with and subtract all the money you put in, you get the interest that you've earned over the life of the annuity. So the total interest is A. Remember, that's the ending value. And then you have to subtract the monthly payment times 12 times T. So the thing to keep in mind in understanding this formula is that 12 times T is the number of payments that you've made over the life of the annuity. So why don't we try an example? Let's say you deposit $700 at the end of each month into a retirement account that pays 7% annual interest, compounded monthly as usual. How much will you have in the account at the end of 45 years? And second question, how much interest will you have earned? So as we saw on the previous slide, you have to answer the first question. You have to find the ending amount in the account in order to answer the second question. So let's start with the ending amount. We've done a calculation like this on a previous slide. We're using the annuity formula, and we're replacing the monthly payment by 700, the annual interest by 0.07, and the number of years by 45. And we get an answer of $2,654,816.27, rounded to the nearest cent. And now, how much of that is interest that you have earned? Well, we take the ending amount and we subtract the amount of money that you've paid in. The ending amount, as we just calculated, is this $2,654,816.27. And we're subtracting the monthly payment times 12 times 45, the monthly payment times the number of months that you paid into the account. And the answer is $2,276,816.27. $816.27. One sort of striking thing here is that a vast majority of the money you end up with is interest that you've earned. So I did the previous calculation on a spreadsheet, and here's what it looks like. This was made from the previous spreadsheet. So as before, I have the monthly deposit in cell A3. I have the annual interest in cell B3, and the number of years is in cell C3. And before, I had calculated the ending value of the annuity and put it in cell B5. So the actual contents of cell B5 is the formula for the ending value of an annuity. And now in cell C6, which is the cell I was in when this screenshot was taken, is the formula for the interest earned on an annuity. Right, the ending amount of the annuity is in cell B5. The monthly deposit is in cell A3, and the number of years is in cell C3. So spreadsheet will save me a lot of time, especially if I have several of these calculations to do. Okay, now the third of the three calculations that we are going to be doing with annuities is finding the monthly deposit given the ending amount. So if you have some ending amount in mind, we're going to see how to find how much you will have to contribute monthly to achieve that ending amount. Okay, so we're going to use the original annuity formula. Here it is again. And one way to do this is simply to plug in the numbers that we know. So if you have an ending amount in mind and you want to know what the monthly payment should be, you could simply plug in the ending amount, plug in the interest rate, plug in the time in years, and solve for your monthly payment. The other possibility for doing this kind of calculation, finding the monthly deposits, is to first solve the equation for PMT and then plug in the numbers. There's a little bit more algebra involved that way. So let's try an example. So let's say you have a retirement account that pays 7% annual interest, compounded monthly as usual. And the question now is, how much do you have to deposit at the end of each month if you want to have $1 million as an ending value at the end of 45 years? So we're taking the annuity formula that we've been using all along, and we are plugging in the ending value of 1 million, the interest rate of 0.07, and the time in years 45. So that results in this equation. And now I'm going to do the calculations. I'm going to leave the 1 million sitting here, and I'm going to calculate this number on the right-hand side of the equation that's multiplied by PMT. So I did that, and what I got was 3,792.594,677. I don't want to do any rounding off at this point. At the very end, I will round off to the nearest cent. But it's best to wait till the end to do any rounding. And now we can find PMT by dividing both sides by this multiplier, dividing both sides by 3,792.594677. So PMT turns out to be $263.67. If you are able to make this monthly deposit every month for 45 years, and if you're earning 7% interest, annual interest, you will end with $1 million. And now let's try the other approach to finding what your payment should be. So the other approach is the one that involves a little bit of algebra. I want to solve this equation for PMT. And actually the algebra is pretty easy. I want to get rid of this divisor, so I multiply both sides by it. I'm multiplying both sides by r over 12. And I want to get rid of this multiplier on the right, this thing in square brackets, so I'm dividing both sides by that. The final result is that the monthly payment will be the ending amount times r over 12 divided by 1 plus r over 12 to the 12t minus 1. And now if we have some numbers to enter to find PMT, we can simply enter them in the right-hand side of this equation. So in our example, the ending amount was supposed to be $1 million. R was 0.07, and T was 45. And as we should expect, we get the same monthly payment required, $263.67. So doing things this way, solving for A first, will make the calculations a little bit easier if you are using a spreadsheet. And here's the spreadsheet that I used for this deposit calculation. So the monthly payment occurs here in cell C6, and what's actually in cell C6 is the formula from the previous slide, with with the final value A replaced by C3 because the value of A appears in cell C3, and so on. And now, as we know, if I want to calculate the payment required for a different set of conditions, I can come back to this spreadsheet and simply change the values appearing here in cells A3 through C3. And now the remainder of these slides consist of the reasons that the formula for annuities works. My plan is to leave this part off of the video, but if you are interested in why the formula works, you can look at the slides, which are also included in this module.